Hello and welcome. Today we're diving into the fascinating evolution of programming languages. It's a story of constant change, driven by new hardware, different ways of building software, and the ever-growing demands of technology. We've journeyed from languages that spoke almost directly to machines, to sophisticated tools that are much closer to how humans think. In the very beginning, programming was literally done in binary code, just ones and zeros. That was the first generation. Then came assembly languages, the second generation. These used simple keywords, making things a bit more readable, but still very much tied to the specific computer hardware. The main goal back then was pure machine efficiency, because computing power was a scarce and precious resource. The 1950s and 60s were a real turning point. Third-generation languages, or 3GLs, arrived. Think of Fortran for scientific calculations, COBOL for business applications, and Lisp for early artificial intelligence work. These languages allowed programmers to write instructions that felt more like human language, hiding many of the complex hardware details. This era also gave birth to core programming philosophies. Procedural programming, where you write step-by-step instructions, was common with languages like C. Then object-oriented programming, or OOP, came along, made popular by C++ and Java. OOP organizes code around objects, instances of classes that bundle data and functions, making complex systems easier to build and manage. And let's not forget functional programming, with roots in Lisp, which treats computation like mathematical functions, leading to cleaner, more predictable code in languages like Haskell. Fast forward to today, and the landscape is incredibly diverse. Languages like Python, Java, and JavaScript remain popular thanks to their flexibility and massive communities. But new trends are constantly shaping what's next. Artificial intelligence and machine learning are huge drivers. Python, with its powerful libraries and newer languages like Julia, designed for high-performance computing, are leading the charge. AI is even being used to help develop new programming languages and optimize code. We're also seeing more domain-specific languages, or DSLs, which are tailor-made for particular tasks, like web development or data science. There's a huge emphasis on performance, security, and concurrency. That's the ability to handle many tasks at once. Languages like Rust and Go are making waves here, with Rust especially known for its focus on memory safety without slowing things down. The need for apps to run everywhere, on any device, has boosted cross-platform development. Cloud computing demands languages like Go and Python that scale well in distributed systems. And even low-code or no-code platforms are emerging, making development accessible to more people. New technologies also demand new tools. Blockchain brought us languages like Solidity for writing smart contracts. The Internet of Things often relies on C, C++, or Python. Augmented and virtual reality development heavily uses C# with Unity and C++ with Unreal Engine. And looking further out, quantum computing, though still in its early days, is expected to bring entirely new types of programming languages. Designing a programming language always involves trade-offs. For instance, super-efficient languages might be harder to read and write. More flexible languages might be less safe, while simpler languages might not be as powerful for complex tasks. So what does the future hold? The evolution isn't stopping. AI will likely play an even bigger role, perhaps one day leading to programming in plain natural language. Well, see, languages hide even more of the underlying complexity, letting developers focus on solving problems. And languages will probably continue to blend different programming styles, offering more flexibility. The constant is change, as we keep searching for better, more efficient, and more intuitive ways to instruct our computers. Thanks for tuning in.